Welcome to a new test and teardown video. I'm a little bit afraid this is also going to be a repair video, but we're going to see if that is the case. I don't know exactly the brand of this one, but it says DIA E AC DC Voltmeter. So I mean, yeah, should do AC and DC plus minus, so you can probably also input. So DC is probably here and AC is here, or is it the other way? It's not that clearly explained. And that will be the ranges and function and the DC nulling. And it says something about a battery, 15 volts minimum, and there are no power cords or nothing on this instrument at all. So I mean, there's definitely a battery in here, so the only thing I can do is to open it first. And also I hear some very funny rattling loose stuff sounds when I shake this carefully. So always when you get old instruments like this, don't shake them, but you can rotate them real slow and listen to loose objects. Yeah, you can hear that, right? So if you take this and shake it real hard, the loose part's gonna knock everything else loose and you're gonna have a damaged instrument, right? But listen. I don't know. Yeah, there's definitely some. Let me open and have a look. So that was real easy. Now I found the explain for the input. So the banana connectors are just directly connected and parallel with the BNC. So that makes everything a lot easier. But look at that. Ground is not chassis. There's a capacitor to chassis just for shielding. This one is our ground, that piece of metal, and then we got all sorts of wires to everything from that piece of metal, and then everything else here metal is ground. But it's not chassis, so this is chassis, right? So we got a little bit of transistors. Okay, that one is a 6-pin device, so that is a dual transistor thing, I guess, right? And it's really beautifully made. We got a very, very big resistor in here, so it can handle a lot of, yes, 1000 volts, so that explains that. Okay, great. 1000. 10 millivolts to 1000. So that is actually quite useful. I mean, this is 1970 kind of style. And back then I think it was pretty neat with that kind of range. So that is the loose sound. Got a little bit of a springy here, soft stuff that was under here. This foam is not so nice, and then there was a little piece of plastic that's probably for the battery connectors here. I mean, the battery says 15 volts minimum. So what is the battery nominal? Yeah, we need to figure that out. Oh, we got a little bit of text written on the PCBs here. Oh, isn't that just sexy? So this is how you do the zeroing. Just so it looks more flat and nice. Ha! That is such a cool device. I mean, that's just a cool way to do it. Why is it? Yeah, okay. And ooh, look at that. So that is not just a very big resistor, but it's also a trimmer capacitor as well. That is interesting. Tantalum, I really kind of hate those, but that is a different kind of thing. So that will be the different ranges calibration. Somebody added some glue. And here it says dia voltmeter. And we also got the same kind of text. On here we got a little bit of tape. Why? This says again dia voltmeter, and that is a B, and then A, B, C, D, la 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 la. What is that then? And we also got some A here. Yeah. Not a lot to say. It looks a lot like a Radiometer clone. Somebody kind of stole the idea. Oh, somebody wrote something on this glass. I almost read a name somebody wrote here in the middle of the screen. I don't know what that is. What is the idea here? So okay, that was the idea. So you take this out, put in your new big special fancy smancy battery pack, and then you're good to go if you remember to turn it off. So I would expect this to use a very, very low current consumption. Yeah, this is a little bit stiff. That's also a little bit. I think I need to clean it a little bit. Yeah, I think I will try and power it up. How about we do that? So here's my take on this. If a battery is okay or acceptable minimum at 15, it's probably 18, because it's two 9-volt batteries in series, right? So it's probably 18, that's the nominal voltage. So this is what I'm giving it. And the voltmeter here also read the voltage. So I guess that is it. And if I reduce the voltage to 15, it goes here. So that's all fine. Then we go to the DC, and it hammers to the negative, and it's not responding to the DC zeroing here, no matter what the heck I do, right? So this is DC positive, and that goes negative, and DC negative, that goes positive. And I don't have any DC voltage here, I got AC voltage here. And the same happens, right? So there's a DC offset kind of thing, but when I go to AC voltage, it goes to 0, right? And this is 10 volts RMS, I would imagine, full range, right? So in this one, I got 1 kilohertz, 3 volt RMS. Okay, if I click that here, that will be the case. Look at that. A little bit more than 3. So, I mean, RMS or AC volts seems to be working, but we got a DC offset kind of problem. That is good news. Or maybe the battery pack is a plus minus 9 in respect to the chassis. So that's also an option. But if that would be the case, I would expect there to be a wire on the battery, right? I don't know. I will probably have to measure if there's any resistance between this black one and the chassis, because that could maybe explain this offset kind of thing, right? See, I got something going on here. 6.7 from the black one to chassis. So this is the ground for the electronics. So yeah, there's definitely a center point, and that is not in the middle. So I mean, there must be two resistors dividing the power supply somehow, right? I could take another power supply and see if I can tweak the center point and see if that affects the zero. By the way, the current consumption is only 3 milliamps. So that is very, very low. And it's even hammering out the... Well, 3 milliamps is all I read no matter what the display does here. So, and here is 0. Okay, well, let's try that. So that's actually interesting. I got now a second power supply, and that is now my chassis to ground offset. So I can pull this. So now I got 3.9 volts, and look at that. It's almost 0. And it is indeed responding a little bit to my 0. More or less how much I would expect this to be. Very, very little, obviously, right? And yeah. Let's try and go positive. And let's try and DC offset about... Yes, that is 1 volt input. 1 volt DC input. We are 3. Yes. That is interesting. So, if I can fix the DC offset problem, the unit will work. So that means all the transistors and amplifiers and fancy stuff is definitely working. There is a leaky capacitor or something. Cool. Let's try and be real accurate here. Offset. Input is now 0 and input is now 1. And it goes to 1. All I did was to trim this and the offset between that one and the chassis. So that will force the 0 input to go to 0 here, right? But also, see, there's almost nothing now. That is good. I'm super happy now. But I don't have a schematic, so I need to figure out where's this offset coming from. Ooh, hello. Of course, I figured this out. But that was not so easy. Who would have guessed? Actually, I was looking around. There's a Zener diode here, and that is, of course, the reference. And when I poked around with this supply rail offset, that will, of course, change the whole balance. All this is a DC coupled balanced coupling. I don't know if it's easy to see, but that is actually what it is. And then this is the final output driver, also a balanced 2-in-1 unit here, and that goes to the meter. So I thought, well, I'm looking for an imbalance. I'm looking for leakage in some of the capacitors here. So I'm like, okay, we just cut one of the pins in one of the sides here and then do a little bit of tweaking around and see if I can figure out where is the leak. And you know what? That is so stupid. The whole mistake. Those two trimmers. Somebody poked around with those without knowing what he was doing. And those are very, very critical to figure out how to do the balance in all this stuff. So why do people touch stuff they don't know what they're doing? That is, I know, not so smart, you know. But anyway, that's probably why this landed on my table. And now look at the zeroing here, huh? And now it's running off an 18 volts supply. And I guess if I take this 18, make it 17, make it 16, it's not affecting this at all. Because there's a perfect balance in the way that I trimmed this thing, right? Go back to 17, 18. Let's give it 1 volt DC. Hubba hubba, yeah. So of course it works. All you have to do is trim it right. So that was fun. It took quite a while to figure this out. I must say, I'm actually a little bit embarrassing how long it took, so maybe I'm not going to reveal how absolutely stupid I was poking around a million other places. You can guess how it is sometimes with misleading clues. Gives you the big walkabout. Yeah. I even poked around with the capacitors here, because it was also looking like somebody soldered here on the top. And then I kind of thought, hey, what if... Nope. Oh, this is perfectly fine. Got some really big resistors and a big red one in here. Super high voltage parts. I really like that pot for zeroing. And by the way, the zeroing pot here is also a very big clue. When there's an offset problem, just follow that wire. See where that goes. We got some balance stuff here. Follow this, yada yada, figure out, ooh, this is not doing anything and it's all the way to one side. Okie dokie, then let's go and figure out the balance. Oh, those goes to those two trimmers. Ooh, they're all wrong. Oh, let's try and poke around here. And bingo bongo. Anyways, thank you very much for watching. I hope you had a little bit of fun. At least I did. See you tomorrow. Bye bye.